Hi everybody, it's Mrs. Costello. This is day 5. We're going to start solving radical equations starting today. And just like solving, systems of equations, there's a few ways you can do it. Today we're going to be focusing on the graphing part. So, hopefully today's video is short and sweet. There's really not a whole lot to the day 5 notes, so let's get to it. The first one is a review, and I want you to describe the domain and range of the function that is right below. To give you a hint, I would look at this. I don't think you need to graph it if you know the shape. So go ahead and pause your video and try to do this review problem now. So just by knowing the shape of a cube root graph, I was able to find the domain and range. Now, I know that this one has a negative coefficient in the front, which flips it, and I kind of drew a little shape right here just to remind myself. So those x's are getting, bigger and smaller. They're going towards positive and negative infinity, and so are the y's. So that's going to be an all real number situation, which is answer choice D. Awesome. So Number two, again, I think you guys could probably do this one on your own, but I'll kind of go through an explanation after, you guys try it on your own. So why don't you go ahead and pause your video and try this review problem on your own as well. All right, on number 2, hopefully you got answer choice C. So the big thing on this one is you have to think about what exactly happens when, A is greater than 0 or less than 0. When it's greater than 0, it's a positive. If it's less than 0, it's a negative. And so that just flips it over the x-axis. Now, let's say you didn't remember it. I gave an example, I pretended, and I plotted one in Desmos. So I'm going to show you that now. So I made 2 graphs. I made a red graph and a blue graph. And the only difference between the red graph and the blue graph is there's a negative in the front of the blue graph. So you can see that the domain is going to be the same for both of them. We can see that the x's are going to be bigger than our h value. And then the only difference is those y's are going to be increasing on our red function or our original function with the positive a value. And the y's are going to be decreasing on the blue function that has the negative a value. So let's go back to our notes. And if we see on our notes, I did kind of look at, okay, do all the domains have x is bigger than, the h value? And I was able to eliminate B and D because they both say that x is less than in their negative, and that's not what's going on. So that's how I got answer choice C. All right, number 3. Number 3 says attempt to solve the equation. Well, if we're going to attempt to solve, I would move everything to one side. So, good luck. Okay, why don't you just pause your video, try to move things to one side, maybe. I don't know. All right, I don't know how far any of you guys got, but here's what I did. I moved everything from the right side onto the left side. Now, when you look at the left side, it does not look beautiful, and we're kind of like, why? So, again, not fun, but from here, you can totally break them apart and try to, I don't know, get matching parentheses and then solve. You can take out, technically you can take out x to the 1/2. You can also multiply everything by 4 to clear out the denominators. Such a mess, right? Do you see why I'm kind of I don't love this? It's honestly not super fun, right? So, yeah. Anyways, don't love this, right? That's kind of why we are going to show you how to solve these. Using graphing or algebraically or whatever, because honestly, it's kind of a pain in the butt to solve, right? Yeah, I don't even think I'm doing it right. But if you wanted to try to do it right, maybe we'll go back to it at the end. Right now, let's go ahead and go to the graphing. So here's how we graph these guys. we are going to set both sides of the equation as their own equation or their own function. And we're going to treat them, separately, kind of like what we do when we're graphing systems of equations. Step 2 is to graph each function individually. And then the solution is where the functions intersect. So far, nothing is different from when you graph a system of equations. We just might be graphing some radical functions or, something else, and we're just going to see where they intersect. So honestly, not awful. All right, we have two graphs. We're going to look at the first one. So on the first one, remember that we're going to do each equation separately. So if it helps you to go, okay, here's my first equation, and I'm going to write y equals x minus 5. And we're only going to focus on that one right now. We're going to ignore the other one. So this one is a linear function, and I know that because there's no exponents, there's no square root, there's none of that. So all I need is the slope and the y-intercept. So my slope is 1, my y-intercept is -5. So I'm going to go up to -5, and then I'm going to go up 1 over 1, up 1 over 1, up 1 over 1, right? You guys know how to do this. And I'm going to draw my line. And you can do as many, up 1 over 1s as you want. It's probably a good idea to do more than like 1 or 2 because you are trying to see where the two graphs intersect. So just saying, it might be smart. All right. Second one, again, we're going to use blue on this one. Now we're talking about a radical function. So if I write y equals square root x plus 7 right here, now I'm focusing on this. So when I'm going to graph this, because it's a square root function, I'm going to look at my h value because that's where I'm going to start. There's no k, so it doesn't shift it up or down. It just is going to shift it to the left. So I'm going to go left 7 because we always change h. 1, 2, 3, 4, 5, 6, 7. And then with our cube root function, I know all the teachers kind of have different styles of teaching it. I go by perfect squares for the over. So we always rise. We're going to always rise 1 and then go over for our perfect squares. So I'm going to go up 1 over 1. That's, square root of 1. Up 1, or up 2, sorry. And then we're doing 4 over 1, 2, 3, 4. Or I know like we're kind of doing 1, 3, 5, but sideways. That's kind of how I teach it, but I know some of the other teachers teach it differently. So then now I'm on my 5. So up 1 over 1, 2, 3, 4, 5. And there we go. Perfect. So they did intersect in one spot. They intersected right here. So that would be my solution. It looks like that's -1, 2, 3, up 2. Perfect. So -3, +2. All right. Now we're going to do the same thing on the second one. Okay. Now, the second one is two radical functions. And I mean, hopefully we're cruising on these, but if it's still kind of hard, that's okay. You always have your graphing calculator, but we can always do these by hand. Okay. This is actually our last problem. That's pretty sweet. So let's rainbow pen it. So I'm going to put y equals square root x minus 3. We're going to start with our HK change, and the only change is that -3. That is our H, so we're going to go right 3. 1, 2, 3, and this is my first point. Now again, all of our teachers kind of have different ways of teaching this. I teach rise 1 over, and then I use the 1, 3, 5 rule. So rise 1 over 1, rise 1 over 3, 1, 2, 3. Rise 1 over 1, 2, 3. Can't go over 5. So that's good enough. All right, so I used rainbow pen for that. I'll use like scale pen for the last one. All right. So this guy, you have to be really careful because your when you do this one, y equals 5 minus the square root of x plus 2, it's really easy to get confused and go, okay, the 5 is the a value. It's not. You always go with like what is directly in front, which is this negative. Okay. If it's going to confuse you, rewrite it because the 5 is actually your k value. It's just in a weird spot. So I'm going to rewrite it just in case you're like, dude, this is bugging me. I feel you. It's okay. So all we're going to do is we're just going to put the 5 at the end where it normally goes. So I'm going to put a negative in the front, square root x plus 2, and then that 5, that k is just going to go in the back. Since it's positive, it's going to be plus 5. And I only did that just so we kind of eliminate some common mistakes. Now you still have your h and your k. And this time we're gonna go down 1 instead of rise 1. So my new starting point is going to be left 2, up 5. 1, 2, 3, 4, 5. All right, and then we're going to go down 1 over 1, down 1 over 3. 1, 2, 3. Down 1 over 5 is the next one. 1, 2, 3, 4, 5. Boom. Yes. Okay. And I'm not going to graph any more dots because all I care about is where they intersect, right? So they intersect right there at 7, 2. So 7, 2 is going to be my solution. Now here's the deal with the solution. You are more than welcome to plug this back in to your equations up here for the x's and make sure that it works. There's not really, I mean, you could also plug them in here if you wanted to use the y's, but you don't have to. So just, if you've got extra time on your test and you're like, I want to make sure I did this right, that's how you would do it. All right, now let's go to way back to that one review at the top. Number 3, right? We did not love this. Okay, we did not love this. What we could do, though, is we could pause and take a second and put it in our graphing calculator. If you're not interested, it's okay. You can, quit the video. It doesn't matter to me, honestly. But if you're curious, why don't you pause your video and put these two equations in your graphing calculator separately and see if you can find the solution. When you unpause the video, you'll see my graphing calculator with the solution. All right, so I told you I would graph these because we noticed solving by hand was a pain in the butt and honestly kind of impossible. So, sorry they're red and green. If you're red and green colorblind, I'm real sorry. But you can see, there's multiple points where they intersect. Oh, that's so fun. That point is very fun. So, 0.552. Yeah, we totally would have gotten that by hand. And then I'm pretty sure it intersects right here too at 2.556. Yeah, good stuff. Anyways, but now we know how to graph these, so we are super pros. All right, that's all I got for you today. So we're just doing a bunch of graphing. Short and sweet video. I hope you enjoy the rest of your day.